What is light? This question has been asked for as long as man has been able to ask any questions at all. Here are 10 facts about this amazing, life-giving phenomenon. 1. The search for its speed. Galileo Galilei, in the early 17th century, attempted to measure the speed of light by having two observers positioned some distance apart, each holding a lantern covered by a screen. One observer would uncover their lantern, and the other would immediately uncover theirs upon seeing the light, aiming to measure the time it took for light to travel between them. The technology and methods available at that time were not precise enough to achieve an accurate measurement. Also in the 17th century, in 1675, the Dutch astronomer Ole Roemer made significant strides in understanding the speed of light. He observed the varying intervals between eclipses of Jupiter's moon Io as Earth moved in its orbit, providing compelling evidence for the finite speed of light. Roemer, with some assistance from Huygens, estimated the speed of light to be about 220,000 kilometers per second, which is about 27% lower than its actual value. In 1849, the French physicist Armand Fizeau conducted a more direct experiment using a beam of light reflected off a rotating toothed wheel. By measuring the speed at which light could travel to a distant mirror and back, he obtained one of the first more accurate measurements of the speed of light. Fizeau came up with a measurement of 313,000 kilometers per second, which was about 5% off light's actual velocity. 2. More accurate estimate. In 1862, French physicist Léon Foucault conducted a groundbreaking experiment to measure the speed of light. Using an ingenious rotating mirror apparatus, Foucault determined that the speed of light was approximately 298,000 kilometers per second, a value remarkably close to the currently accepted figure of 299,792,458 meters per second, being within 0.6% of its current accepted value. His meticulous experiment not only contributed to the refinement of this fundamental constant, but also showcased the precision of his scientific methods. 3. Attempt to detect the ether. Conducted in 1887 by Albert A. Michelson and Edward W. Morley, this famous experiment aimed to detect the motion of the Earth through the hypothetical luminiferous ether, a medium believed to carry light waves, which was a popular hypothesis at the time. Surprisingly, the experiment yielded a null result, but it did show that the speed of light is constant for all observers, regardless of the Earth's motion, a crucial result for the development of Einstein's theory of special relativity. 4. Constant for all observers, regardless of motion. Probably one of the most amazing facts about light is this one. One of the central principles of Einstein's theory of special relativity is that the speed of light is constant for all observers, regardless of their own motion. To give an example of this, if you were on a train going 100 kilometers an hour shining a flashlight, instead of the speed of light from the flashlight being its regular value, plus the 100 kilometers an hour from the train, the speed of light remains the same, not adding the train's speed. This amazing property of light has implications for both time dilation and length contraction for things with mass, especially at higher speeds. 5. Cosmic speed limit. Einstein's theory of relativity also introduced the idea that nothing with mass can reach or exceed the speed of light. As objects with mass approach the speed of light, their energy requirements for further acceleration become infinite, making it practically impossible to reach or surpass this cosmic speed limit. 6. Light refraction. The speed of light can vary when it travels through different materials, such as air, water, or glass. This phenomenon is known as refraction and results from interactions between light and the atoms or molecules in the medium. These interactions can cause light to slow down and change direction. 7. Wave-particle duality. Light exhibits both wave-like and particle-like properties, known as wave-particle duality. This concept is a fundamental aspect of quantum mechanics. In some experiments, light behaves like waves, showing interference and diffraction patterns, while in others it behaves as discrete particles called photons. 8. Photosynthesis. Photosynthesis is the remarkable process by which light is essential. In the chloroplasts of plant cells, light energy is absorbed by chlorophyll molecules, which then powers the conversion of carbon dioxide and water into glucose and oxygen. This process not only provides plants with their primary source of energy, but also plays a critical role in producing the oxygen we breathe. Essentially, photosynthesis is nature's way of harnessing light to create the foundation of the food chain and maintain the balance of oxygen and carbon dioxide in the Earth's atmosphere. 9. Used in fiber optics. Light is harnessed in fiber optics to transmit data at incredible speeds. Inside an optical fiber, pulses of light represent digital information. This technology relies on the principle of total internal reflection, where light is constantly bounced off the inner walls of the fiber, allowing it to travel great distances with minimal signal loss. By manipulating the intensity and wavelength of light, fiber optics enables high-bandwidth data transmission, making it indispensable for modern telecommunications and high-speed internet connections. 10. Implications on causality. The constant speed of light, laid out by Albert Einstein in his theory of special relativity, has a profound impact on causality. It means that the speed of light in a vacuum is always the same, no matter how fast you're moving or where you are. This leads to a surprising conclusion. Events that are simultaneous for one person might not be simultaneous for another if they're moving relative to each other. In other words, time can appear to pass at different rates for different observers. This idea, called time dilation, challenges our common-sense notion of now and suggests that causality, the order of cause and effect, can vary depending on your perspective when you're traveling at high speeds. It's a fundamental concept in Einstein's theory of relativity and has far-reaching implications for our understanding of the universe. We thank you for watching. Please like and subscribe for more interesting facts about our world.